National Electrical Code Section 300.11a on and ATWO addresses securing and supporting wiring and boxes in both fire-rated and non-fire-rated drop ceilings. Let's break down the requirements for each type of ceiling. First, let's talk about fire-rated drop ceilings. According to 300.11a on, in fire-rated drop ceilings, all wires and boxes must be secured and supported independently of the drop ceiling grid system. The only exception to this rule is if the grid system is specifically listed as suitable for supporting such loads. This means that you cannot rely on the drop ceiling grid to support the weight of the wiring and boxes. You must use independent supports, such as wires or straps, to secure them to the building structure above. Now, let's consider non-fire-rated drop ceilings. In non-fire-rated drop ceilings, as per 300.11 ATWO, fixtures, wires, and boxes must be securely fastened to the drop ceiling grid. This means that you can use the drop ceiling grid to support the weight of these items, provided that they are securely attached to the grid. The National Electrical Code Handbook mentions that luminaries, also known as light fixtures, are not to be supported by the grid in fire-rated drop ceilings. This reinforces the requirement that luminaries in fire-rated drop ceilings must be independently supported. In non-fire-rated drop ceilings, the luminaries section allows you to either tie up or secure the luminaries to the grid, but only if the system is rated for the weight of the luminaries. This means that you need to check the grid's paperwork to ensure that it can handle the load. So, to summarize the requirements, in fire-rated drop ceilings, all wires, boxes, and luminaries must be independently supported. In non-fire-rated drop ceilings, wires, boxes, and luminaries can be mechanically fastened to the grid, but only if the grid is rated for the weight. While the code allows for securing wires, boxes, and luminaries to the grid in non-fire-rated ceilings, it is generally considered best practice to independently support all of these items regardless of the fire rating of the drop ceiling. This approach provides an extra level of safety and ensures that the wiring, boxes, and luminaries will not fall down in the event of a fire or other emergency. In situations where independent support is chosen, it is crucial to select appropriate hardware and techniques that comply with the National Electrical Code and industry standards. This includes using listed supports, ensuring proper spacing and securement, and protecting conductors from abrasion. For example, when using wire to support a box, the wire should be of sufficient gauge and strength to carry the weight of the box and its contents. The wire should also be securely fastened to both the box and the building structure above. When using straps or other hardware, make sure they are listed for the intended application and installed according to the manufacturer's instructions. In addition to the requirements for securing and supporting wiring and boxes, it is also important to consider the overall design and installation of the electrical system in a drop ceiling. This includes ensuring that the wiring is properly sized for the load, that the overcurrent protection is adequate, and that the system is grounded and bonded correctly. It is also important to consider the accessibility of the wiring and equipment for future maintenance and repairs. The National Electrical Code contains specific requirements for these aspects of electrical installations, and it is essential to comply with all applicable codes and standards. When working with electrical systems, always prioritize safety. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following safe work practices. If you are not qualified to perform electrical work, it is always best to hire a licensed electrician. Now, let's delve deeper into the technical aspects of complying with National Electrical Code Section 300.11a on and ATWO. We'll explore specific methods and materials that can be used to ensure proper support and securement of electrical components in both fire-rated and non-fire-rated drop ceilings. Firstly, independent support methods for fire-rated ceilings. In fire-rated ceilings, the primary goal is to maintain the integrity of the fire-resistant barrier. Therefore, any penetrations or attachments to the ceiling structure must not compromise its fire rating. Several methods can be employed to achieve independent support. One option is to use threaded rods suspended from the building's structural members above the ceiling. These rods can be attached to the building structure using concrete anchors, beam clamps, or other approved fasteners. The electrical boxes and wiring can then be secured to the threaded rods using appropriate hardware, such as strut clamps or cable ties. Another method is to use trapeze hangers, which consist of two vertical supports connected by a horizontal crossbar. The trapeze hangers can be attached to the building structure in a similar manner as the threaded rods. The electrical boxes and wiring can then be supported by the crossbar. When selecting independent support methods, it is crucial to consider the weight of the electrical components being supported, the spacing between supports, and the fire rating requirements of the ceiling assembly. It is also important to ensure that the supports are properly installed and that they do not create any undue stress on the ceiling grid. Secondly, securement methods for non-fire rated ceilings. In non-fire rated ceilings, the requirements for support and securement are less stringent, but it is still important to ensure that the electrical components are properly attached to the ceiling grid. Several methods can be used to achieve this. One option is to use listed grid clips, which are specifically designed to attach electrical boxes and wiring to the T-bars of the ceiling grid. These clips typically feature a locking mechanism that securely fastens the box or wiring to the grid. Another method is to use cable ties or straps to secure the wiring to the grid. When using cable ties or straps, it is important to ensure that they are made of a durable material and that they are properly tightened to prevent the wiring from slipping or sagging. For heavier items such as luminaries, it may be necessary to use additional support such as safety wires or chains. These supports should be attached to both the luminaire and the building structure above the ceiling. When selecting securement methods, it is important to consider the weight of the electrical components being supported, the type of ceiling grid being used, and the potential for vibration or movement. It is also important to ensure that the securement methods do not damage the ceiling grid or create any sharp edges that could damage the wiring. Thirdly, considerations for luminaires. Luminaires, or light fixtures, present unique challenges for support and securement in drop ceilings. Their weight, size, and shape can vary significantly, requiring careful consideration of the support methods used. In fire-rated ceilings, luminaires must be independently supported, as previously discussed. This typically involves using threaded rods, trapeze hangers, or other approved methods to attach the luminaire to the building structure above the ceiling. In non-fire-rated ceilings, luminaires can be supported by the ceiling grid, provided that the grid is rated for the weight of the luminaire. However, it is still important to ensure that the luminaire is securely attached to the grid and that it is not putting undue stress on the grid components. One common method for supporting luminaires in non-fire rated ceilings is to use hanger wires. Hanger wires are typically attached to the luminaire at multiple points and then suspended from the ceiling grid. The wires should be of sufficient gauge and strength to support the weight of the luminaire, and they should be properly secured to both the luminaire and the grid. Another method is to use grid clamps, which are designed to attach luminaires directly to the T-bars of the ceiling grid. These clamps typically feature a locking mechanism that securely fastens the luminaire to the grid. When selecting support methods for luminaires, it is important to consider the weight of the luminaire, the type of ceiling grid being used, and the potential for vibration or movement. It is also important to ensure that the support methods do not interfere with the operation of the luminaire or create any safety hazards. Fourthly, code-compliant materials and hardware. To ensure compliance with National Electrical Code Section 300.11a on an ATWR, it is essential to use code-compliant materials and hardware for supporting and securing electrical components in drop ceilings. This includes using listed supports, fasteners, and wiring methods. Listed supports are those that have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories UL or Electrical Testing Laboratories ETL. These supports are designed to meet specific performance requirements and are labeled with the testing laboratory's mark. Using listed supports provides assurance that the supports are capable of safely supporting the weight of the electrical components. Listed fasteners are those that have been tested and certified for use in specific applications, such as attaching electrical boxes to concrete or steel. These fasteners are designed to provide a secure and reliable connection, and they are labeled with the testing laboratory's mark. Using listed fasteners ensures that the electrical components are properly attached to the building structure or ceiling grid. Listed wiring methods are those that have been approved for use in specific locations and applications. These wiring methods are designed to provide safe and reliable electrical connections, and they are labeled with the testing laboratory's mark. Using listed wiring methods ensures that the electrical system is properly installed and that it meets all applicable code requirements. In addition to using listed materials and hardware, it is also important to follow the manufacturer's instructions for installation. This includes using the correct tools, tightening fasteners to the proper torque, and ensuring that all components are properly aligned. Fifthly, inspection and maintenance. Once the electrical system has been installed in a drop ceiling, it is important to perform regular inspections and maintenance to ensure that it remains in safe and code-compliant condition. Inspection should be performed at least annually and more frequently in areas where there is a high risk of damage or deterioration. During inspections, look for signs of damage such as cracked or broken supports, loose fasteners, and damaged wiring. Also check for signs of corrosion, which can weaken the supports and fasteners. If any damage or corrosion is found, it should be repaired or replaced immediately. In addition to visual inspections, it is also important to perform electrical testing to ensure that the system is functioning properly. This includes testing the insulation resistance of the wiring, the continuity of the grounding system, and the operation of the overcurrent protection devices. Any electrical problems should be corrected by a qualified electrician. Regular maintenance is also essential to ensure the long-term reliability of the electrical system in a drop ceiling. This includes cleaning the luminaires to remove dust and debris, tightening loose connections, and replacing worn or damaged components. By following these guidelines for inspection and maintenance, you can help to ensure that the electrical system in a drop ceiling remains safe and code compliant for many years to come. Sixthly, practical examples. Let's consider some practical examples of how National Electrical Code Section 300.11a on an ATWO might be applied in real-world situations. Example 1 involves a fire-rated drop ceiling in an office building. In this scenario, all of the wiring, boxes, and luminaires must be independently supported from the building structure above the ceiling. This could be achieved by using threaded rods suspended from the concrete slab above, with strut clamps used to secure the wiring and boxes to the rods. The luminaires could be supported by trapeze hangers attached to the threaded rods. Example 2 involves a non-fire rated drop ceiling in a retail store. In this case, the wiring, boxes, and luminaires can be supported by the ceiling grid, provided that the grid is rated for the weight of the components. Grid clips could be used to attach the wiring and boxes to the T-bars of the grid, while hanger wires could be used to support the luminaires. However, even in this non-fire rated scenario, it may be prudent to independently support the heavier luminaires to provide an extra margin of safety. Example 3 involves a data center with a drop ceiling used to conceal cabling and equipment. In this type of environment, it is particularly important to ensure that the wiring and equipment are properly supported and secured to prevent them from falling and causing damage or disrupting operations. Independent supports, such as threaded rods and trapeze hangers, would be the preferred method in this case, regardless of whether the ceiling is fire-rated or not. These examples illustrate the importance of understanding the specific requirements of National Electrical Code Section 300.11a on an ATWO and applying them appropriately to different situations. By following the code and using best practices, you can help to ensure that electrical systems and drop ceilings are safe, reliable, and code compliant. Seventhly, documentation and record keeping. Proper documentation and record keeping are essential for ensuring the long-term safety and compliance of electrical systems and drop ceilings. This includes maintaining accurate records of the design, installation, inspection, and maintenance of the system. The documentation should include detailed drawings showing the location of all wiring, boxes, and luminaires, as well as the support methods used. The drawing should also indicate the fire rating of the ceiling, if applicable. In addition to the drawings, the documentation should also include a bill of materials listing all of the components used in the system, including the manufacturer's name, model number, and listing information. The documentation should also include copies of all inspection reports and maintenance records. These records should be kept for the life of the system and should be readily available for review by inspectors or other authorized personnel. Proper documentation and record keeping can help to ensure that the electrical system is properly maintained and that any problems are identified and corrected in a timely manner. It can also be invaluable in the event of a fire or other emergency, providing critical information to first responders and investigators. Eighthly, training and competency. Working with electrical systems and drop ceilings requires specialist knowledge and skills. It is essential that anyone involved in the design, installation, inspection, or maintenance of these systems is properly trained and competent. Training should include a thorough understanding of the National Electrical Code, as well as best practices for supporting and securing electrical components in drop ceilings. Training should also cover the proper use of tools and equipment, as well as safety procedures. Competency can be demonstrated through certification or licensing, as well as through experience and on-the-job training. It is important to ensure that all personnel working on electrical systems and drop ceilings are qualified to perform the work safely and effectively. Ninthly, future trends and technologies. As technology continues to evolve, there are likely to be new trends and technologies that impact the design, installation, and maintenance of electrical systems and drop ceilings. For example, the increasing use of LED lighting is leading to lighter and more energy-efficient luminaires, which may reduce the need for heavy-duty supports. Similarly, the development of new wiring methods and support systems may simplify the installation process and improve the reliability of the system. It is important to stay abreast of these trends and technologies and to adapt your practices accordingly. This can involve attending industry conferences, reading trade publications, and participating in continuing education courses. By embracing new technologies and adapting to changing trends, you can help to ensure that electrical systems and drop ceilings remain safe, efficient, and code compliant. Lastly, safety considerations. Throughout all stages of working with electrical systems and drop ceilings, safety should always be the top priority. This includes following all applicable safety regulations, using appropriate personal protective equipment, and implementing safe work practices. Before beginning any work, it is essential to de-energize the circuit and verify that it is de-energized using a voltage tester. Personal protective equipment such as safety glasses, gloves, and hard hats should be worn at all times. Safe work practices include using proper lifting techniques, avoiding working in wet or damp conditions, and keeping the work area clean and organized. It is also important to be aware of potential hazards such as asbestos or other hazardous materials that may be present in the ceiling. If you are not qualified to handle these materials, you should contact a professional abatement contractor. By following these safety considerations, you can help to prevent accidents and injuries and ensure that the work is performed safely and efficiently. Remember, working with electrical systems can be dangerous, but by following the code, using best practices, and prioritizing safety, you can minimize the risks and ensure a successful outcome. The National Electrical Code is not just a set of rules, it is a comprehensive guide to safe electrical installations. By understanding and applying the code, you can help to protect people and property from the hazards of electricity.